Welcome to CosmoQuest 88. Tonight we cast our minds beyond the familiar glow of our sun, beyond the farthest reaches of our solar system, to the ultimate frontier. A journey that transcends generations, technologies, and perhaps even our current understanding of time itself. Close your eyes if you wish, and let your spirit drift to the silent, waiting void between the stars. Tonight, we dream of the ships of infinity. Have you ever looked up at the night sky, at the countless pinpricks of light, and felt an irresistible pull? A longing to reach out, to touch those distant suns, to know what lies beyond? For all our advancements, for all our robotic probes that have ventured to the edges of our planetary neighborhood, humanity remains tethered to a single star. The sheer, unfathomable distances between stars make interstellar travel seem like a fantasy, a realm of science fiction. But what if this seemingly insurmountable barrier is merely a challenge, a puzzle waiting for human ingenuity to solve? What if the destiny of our species is not to remain confined to this cosmic shore, but to become true voyagers of the void, navigating the vast ocean of interstellar space? This is the story of humanity's most ambitious dream: to build the ships of infinity and journey to the stars. Our journey to the stars began not with rockets, but with observation. For millennia, the stars were fixed points of light, divine, eternal. But with the advent of scientific inquiry, we began to understand their true nature. Distant suns, some larger, some smaller, some hotter, some cooler than our own. We learned that they were the crucibles of creation, forging the very elements that make up our world and our bodies. The idea of traveling to them, however, remained firmly in the realm of myth and fantasy. The distances were too vast, the speeds required too immense, the energy demands too astronomical. Even light, the fastest thing in the universe, takes years to cross the void between stars. Proxima Centauri, our nearest stellar neighbor, is over 4 light-years away. A conventional rocket, traveling at its fastest, would take tens of thousands of years to reach it. This is not a journey for a single human lifetime. But the human spirit is not easily deterred. The mid-20th century, the dawn of the space age, ignited a new wave of scientific and engineering thought dedicated to this seemingly impossible task. Visionaries began to propose concepts for interstellar probes and starships. Project Orion, in the 1950s and 60s, envisioned massive spacecraft propelled by nuclear explosions, literally riding on the shockwaves of atomic bombs. It was a bold, dangerous, and ultimately unfeasible idea, but it showed the raw power of human imagination. Later, Project Daedalus, in the 1970s, designed a fusion-powered interstellar probe, a colossal, unmanned vessel that could reach Barnard's star in about 50 years. These early designs, though never built, laid the groundwork, pushing the boundaries of what was considered possible. They transformed the dream of interstellar travel from pure fantasy into a problem of engineering, albeit one of immense scale. If you find this journey into the boundless future of human exploration as captivating as I do, consider subscribing to CosmoQuest 88. By joining us, you help us continue to explore these profound questions and bring the wonders of the universe to you. Simply click the subscribe button below. Your support means the universe to us. The fundamental challenge of interstellar travel is speed. To traverse the immense distances between stars in a reasonable time frame, we need to approach a significant fraction of the speed of light. This requires propulsion systems far beyond anything currently available. Chemical rockets, which have served us well for interplanetary travel, are simply too slow and inefficient. Nuclear propulsion, as envisioned by Orion, offers more power, but comes with its own set of immense challenges. Fusion rockets, like those proposed for Daedalus, harness the power of controlled nuclear fusion, offering far greater exhaust velocities and efficiencies. While fusion power is still in its experimental stages on Earth, its potential for star travel is immense. Imagine a starship, a true ship of infinity, burning miniature suns in its engines, accelerating for years, then coasting for decades, before decelerating at its destination. The engineering required would be staggering, demanding materials that can withstand extreme temperatures and radiation, and systems that can operate flawlessly for half a century or more. Beyond fusion, even more exotic concepts are being explored. Ion propulsion, which uses electric fields to accelerate charged particles, is already in use for some deep space probes, offering incredibly high exhaust velocities, though with very low thrust. It's a slow but steady push that could eventually build up to impressive speeds over decades. Then there are light sails, vast ultra-thin membranes propelled by the pressure of photons from a powerful laser array or even the sun itself. Imagine a spacecraft the size of a small city, unfurling a sail thousands of kilometers across, catching the light like a cosmic clipper ship, gradually accelerating to relativistic speeds. The Breakthrough Starshot initiative, for example, aims to send tiny gram-scale probes to Alpha Centauri using powerful ground-based lasers to accelerate light sails to 20% of the speed of light, reaching the system in just 20 years. What do you think is the most promising propulsion technology for reaching the stars? Nuclear fusion, light sails, or something else entirely? Share your thoughts in the comments below. We would love to hear your vision for interstellar travel. But speed is only one part of the equation. The journey itself presents immense obstacles. Interstellar space, while often depicted as an empty vacuum, is not entirely so. It contains sparse but energetic particles, dust grains, and cosmic rays. Even a tiny speck of dust, encountered at a significant fraction of the speed of light, could be catastrophic for a starship. Shielding against such impacts and against the constant barrage of radiation is a monumental engineering challenge. Then there's the question of navigation. How do you steer a vessel across light years of space, arriving precisely at a target star system that is constantly in motion? It requires unprecedented precision in astrometry and sophisticated autonomous navigation systems capable of correcting course over decades. And what about the crew? A journey lasting decades or even centuries would require solutions for human longevity, psychological well-being, and social cohesion. Generation ships, where multiple generations live and die aboard the vessel before reaching the destination, are one concept. Another is suspended animation or cryosleep, putting the crew into a state of metabolic stasis for the duration of the journey. The ships of infinity are not just technological marvels. They are also complex ecosystems, designed to sustain life and hope across the void. This intricate dance of human ingenuity and cosmic ambition is a testament to our species' drive to explore and to endure. If you believe in this quest, if you feel that sense of wonder, I invite you once more to subscribe to Cosmo Quest 88. Become part of a community that looks up at the stars and asks the big questions. Your subscription is the fuel for our shared exploration. The ultimate goal of interstellar travel is not merely to reach another star, but to find another home, another place where humanity can flourish. This brings us back to the exoplanets we discussed in our previous journey. The discovery of thousands of exoplanets, many of them in habitable zones, has dramatically increased the number of potential destinations. Imagine arriving at a star system after a century-long voyage and finding a world teeming with life, a vibrant ecosystem waiting to be explored, or perhaps a barren world, ripe for terraforming, a new canvas for humanity to paint its future. The dream is not just to survive, but to expand, to diversify, to ensure the long-term survival of our species by spreading our presence across the galaxy. It is a profound shift in perspective, from a single planet species to a multistellar civilization. But what are the ethical implications of such a grand endeavor? If we arrive at a world with indigenous life, even microbial, what is our responsibility? Do we have the right to colonize, to terraform, to potentially alter or even destroy existing ecosystems? What if the journey changes us, transforms us into something no longer entirely human, adapted to the void? And what if, after all the effort, all the sacrifice, we arrive to find nothing? Just another silent, empty world. These are not just scientific or engineering questions. They are deeply philosophical ones. They force us to confront our place in the universe, our role as potential cosmic architects or destroyers, and the very definition of what it means to be human across unimaginable distances and timescales. What do you believe is humanity's greatest responsibility when contemplating interstellar travel and the colonization of new worlds? Is it to preserve life, to expand our species, or to seek knowledge above all else? Share your thoughts and perspectives in the comments section below. We value your contribution to this grand conversation. So, as we conclude our journey tonight, let us remember that the ships of infinity are not just vessels of metal and energy. They are vessels of hope, of curiosity, and of the unyielding human spirit. They are a testament to our desire to know, to explore, and to endure. The dream of interstellar travel is a dream of overcoming limits, of transcending our origins, and of embracing a future where the stars are not just distant lights, but destinations. It is a dream that will challenge us, transform us, and ultimately define us. And as we continue to gaze at the night sky, we know that somewhere in the minds of engineers, scientists, and dreamers, the blueprints for those ships of infinity are slowly, patiently being drawn. Thank you for joining us on Cosmo Quest 888. If this exploration of interstellar travel has deepened your sense of wonder, please subscribe to our channel to continue these journeys of discovery. Until next time, may your dreams carry you to the farthest stars. Good night.